Hi everyone, and welcome to this first episode in our Arduino series. If you are new to electronics or just curious about how things work, you are in the right place. So, what is Arduino exactly? Arduino is an open source electronics platform that lets you build all kinds of smart devices from blinking lights to home automation systems and even robots. Technically, Arduino is built around a microcontroller, which is just a small ephemeral computer on a single chip. It has a processor, memory, and inputs and outputs that let it control things in the real world. For example, the Arduino Uno, one of the most popular models, uses a microcontroller called the AT 8. It has built-in memory, inputs for sensor, and outputs to control things like LEDs or motors. The best part, it is super beginner friendly. You can write simple code on your computer and upload it to the Arduino with just a USB cable. Now that we know Arduino is based on a microcontroller, let's take a closer look at what that really means. A microcontroller is like a tiny computer that's built to control things. It has a processor, memory, input, output pins, all packed into a single chip. These chips are designed to be embedded inside other devices. For example, they're used in washing machines, cars, game controllers, and of course, in Arduino projects. The Arduino Uno uses a chip called the AT 8. It has 32 kilobit of storage for your code, 2 kilobit of working memory, and 1 kilobit to store saved data. That might not sound like much, but it is more than enough for tons of amazing projects. So think of the Arduino as a tiny consumable brains. It takes input from the world like light, sound, or motion and turns that into action, like turning on a light or moving a motor. All right, let's look at the different types of Arduino boards. There isn't just one model, and each has its own strengths depending on what kind of project you want to build. First, we have the Arduino Uno. This is the go-to board for beginners. It is reliable, well documented, and works with almost all sensors, motors, and starter kits. Need something more powerful? Meet the Arduino Mega 2560. It has way more pins, 54 digital and 16 analog, which makes it ideal for complex bits like 3D printers, CNC machines, or anything with lots of components. Then there is the Arduino Nano. This one's much smaller but still powerful. It has the same microcontroller as the Uno, but it's perfect for compact projects or wearable devices. Finally, we have the Arduino Leonardo. It is unique because it can act like a USB device, such as a keyboard or mouse. If you're into building custom game pads, MIDI controllers, or USB automation tools, this is a fun board to explore. The cool part is that all of these boards use the same Arduino software and programming language. So once you learn one, switch to another is easy. Of course, we have the other type of Arduino, and if you are a little more curious, you can make your own Arduino like a DIY Arduino. Let's do a quick side-by-side comparison to help you choose the right Arduino board for your project. First, the Arduino Uno. 14 digital pins, 6 analog pins, and a USB-B port is great for beginners and general purpose use. Now, the Arduino Mega 25660. This one is a beast. It has 54 digital pins, 16 analog pins, and uses the same USB-B port as the Uno. Ideal for like scale bits like robotics or anything with a lot of components. Next, the Arduino Nano. It also has 14 digital pins but gives you 8 analog inputs and is tiny. It uses a mini USB or USB-C port depending on the version. perfect for small or portable projects. And finally, the Leonardo, it gives you 20 digital pins, 12 analog inputs, and uses a micro USB port. It is best known for acting like a keyboard or mouse, so it is great for USB interface projects. So the board you pick depends on what you want to build. Something simple, go with the. Something compact, try Venado. Something big, mega. Something creative with USB, Leonardo. You might be wondering who actually uses Arduino. Is it just for techs, nerds, or engineers? The answer is everyone. Arduino is used by hackers and makers who love DIY tech, engineers and students who prototype real systems, artists and musicians who make interactive installations, teachers and kids who are learning electronics for the first time. And yes, even people like you who just want to be cool stuff. Whether you building your first blinking LED or a full robot, Arduino is accessible, powerful, and made for creative minds at any level. Okay, let's talk about the fun part. What can you actually build with Arduino? The truth is almost anything you can imagine. Let's start with the basics. You can control LEDs, buzzers, and motors. You can read data from temperature sensors, light detectors, or even motion sensor. You can make a digital thermometer, a smart light that reacts to movement, or a single panel with push buttons and sounds. These projects are perfect if you just get started. And once you understand the basics, it opens the door to more advanced bits like weather stations, robotic arms, smart plant weathering system, and even IoT devices that connect to the internet. Seriously, if you can dream it, you can probably be it with Arduino. Let's take let's take it a step further. Once you're comfortable with basic components, you can build projects that are actually useful or interactive. How about a motion activated light system using a PIR, a PIR sensor, or a digital display that shows temperature or humidity? You could even make a simple security alarm using a buzzer and push button. You can also learn how to control servos, wait for buildings, robotics arms, automatic blinds, or permanent cameras. This project helps you understand how real-world devices are built, and it gives you hands-on practice with sensors, logic, and feedback system. Now let's look at some more advanced and creative projects you can build once you master the basics. You could create a smart weather station using temperature, humidity, and pressure sensor, and even have it log data online. Or maybe you want to automate your home, turn on a fan when it gets hot, or use a relay to control lights from your phone using Bluetooth or Wi-Fi. People have built RC cars controlled by a smartphone, gesture-based robot, and DIY music instruments, and even automated plant watering systems that sense soil moisture. Arduino projects can be both fun and powerful, and they're an amazing way to explore robotics, automation, and even smart home technology. Let's quickly recap by Arduino is such a powerful platform, especially for beginners and creative minds. First, it is open source and affordable. You don't need a big budget to get started. Second, it is ideal for rapid prototyping. You can test ideas fast without needing a full engineering team or custom hardware. First, it works with a huge variety of sensors, actuators, and modules from LEDs to Wi-Fi chips. It also incredibly useful across many fields, education, science, art, and even light industrial application. It uses a very little power, which makes it great for portable or battery power projects. And finally, The Arduino platform is flexible. It combines simple hardware with beginner-friendly software, making it accessible to anyone. So whether you building your first blinking LED or creating a custom smart device, Arduino gives you the tools to bring your ideas to life easily and affordably. Let's look at where Arduino is actually used and why it's such a valuable tool beyond just hobby projects. Arduino is used in schools and universities around the world to teach electronics, coding, and robotics. It is affordable, handsome, and helps students understand how real-world systems work. Arduino is a favorite in labs and maker spaces because it lets you quickly test and validate ideas, whether you're collecting environmental data, controlling devices, or automating simple processes. Arduino is ideal for fast experimentation. While you won't find Arduino boards in mass-produced consumer products, they are often used in early-stage development. Engineers use them for proof of concept, internal tools, and even factory automation prototypes. So whether you're in school, in a lab, or even at work, Arduino helps bridge the gap between imagination and implementation. Now let's get practical. What do you actually need to start building with Arduino? You don't need a lab or expensive equipment. A basic starter kit will give you everything you need to follow along with these courses and start experimenting. Here are some of the key components you typically find inside a beginner-friendly kit: an Arduino board, usually the Uno, a USB cable to connect it to your computer, a breadboard for building temporary circuits, jumper wires to connect components, a mix of LEDs, the red, green, or blue resistor, usually 220 to 1000 ohms, button, buzzer, we have active and passive, sensors like temperature sensors, light sensors, or thermistors, displays, sometimes 7 segment or LED matrix, and more, all packed to help you build dozens of beginners projects. Most of these kits are really affordable and available online. I highly recommend starting with one. It saves you time and helps you build a wide range of projects right away. All right, let's take a closer look at a tool you'll be using all the time, the breadboards. It might look confusing at first, but it is actually one of the simplest and most helpful tools in electronics. A breadboard is a plastic board filled with tiny metal clips inside. These clips allow you to plug in components without needing to solder anything, so you can build, test, and change your circuits easily. Let's break it down. The two long walls on each side are called powerways. Their visually labeled plugs and minus are used to distribute power across your whole board. You typically connect this to the 5 volt and J and D pins from your Arduino. The middle area has vertical columns of O's grouped in sets of 5. Each group is connected horizontally, not vertically, meaning all 5 O's in a row are electrically connected. That's where you place components like resistors, LEDs, and sensors. There's also a gap in the middle. This separates left and right halves, and it's just wide enough to fit something like a microcontroller or chip. For example, to light up an LED, you place the LED legs across two walls. Use a resistor to limit the current and then connect wires from the power ways to those walls. Once powered by the Arduino, your LED will light up. We're gonna make an example that you can understand. And here's is a tree. Each side of the breadboard is electrically separate, so you can build two circuits at once if needed. Also, some power rails are connected end to end. So if yours doesn't work, just try bridging the gaps with jumper wires. The breadboard is where most of your learning will happen. It's the safe space for trial and error, and it makes prototyping fast, simple, and fun. So, to sum up, the breadboard is made up of rows and columns that let you connect components together. The side strips, marked plus and minus are used to distribute power often from the Arduino. When you plug wire into one of these ways, the entire row is powered. Keep in mind that each side of the board is independent. Is independent. The central rows are a bit different. Each group of five connectors, label A to E and F to G, is connected horizontally, but the two sides do not communicate with each other. So understanding how the breadboard works is very important because you're gonna use it anywhere and everywhere. For example, in Raspberry prototyping, Yocto project, Zimbozing, and of course, the ESB32. Now that we've talked about the different types of Arduino boards, let me show you ones I actually use. First up, we have the Arduino Uno. The Arduino Uno, probably the most famous and beginner-friendly board. It's my go-to for testing new components, basic tutorials, and most of the projects you see in these courses. It has 14 digital pins, 6 analog pins, and using the B, the USB B, uh, the USB B connector. It's big enough to be easy, but small enough for compact projects. Next is the Arduino Mega 2560. It looks like this. And as you can see, it is much larger. That because it is built for complex projects that need a lot of connections, like robotics, automation on anything with a display, multiple sensors, or motors. It has a massive 54 digital pins and 16 analog inputs, so it is a beast in terms of flexibility. And here's the Arduino Nano. The Arduino Nano, it looks like this. Okay, the Arduino Nano, super compact but still powerful. It actually uses the same microcontroller as the Uno, but in a much smaller package. It's perfect for small builds, wearable tech, or when you want something light and minimal. So whether you want control, you want something simple, something compact, or something big and powerful, these three boards cover almost everything every beginners and intermediates need. And the best part, all of them use the same Arduino code and programming style. So once you learn one, you can use them all. All right. It is time for you. It is it is time for your first very handsome Arduino project, and it starts with a classic turn on an LED. This simple circuit is like the hello world of electronics. Here is what you need for this setup. An Arduino Uno. You need an Arduino Uno. Uh, an Arduino Uno. Some LEDs. Some LEDs. A resistor, ideally. Some resistors. Okay, we have some resistors here. You're gonna need it. Jumper wires. Jumper wires. A USB cable to connect the Arduino to your computer. Here it is. USB cable. This one is for the Uno. And the for the for the Arduino Uno, The cable looks like this. Make the difference between the USB cable between Arduino Uno and Arduino Nano. They are both different. They are different. Insert an LED across row 29, 30. Pay attention to the foot or the legs of the LED if you want. Uh, Sorry. Okay. Okay. Then use two wires to bring power from the Arduino, one from the 5-volt pin positive and the other from the GND pin ground. Where is my Arduino? Okay, okay. The the black one is for GND. The red jumper wire is for uh 5 volts. Okay, right. These are plugged into the plus and minus way of the breadboard. Then takes two more wires and connect them from those power waves to the rows where the LED is placed. Okay. All right. Okay. Okay, right. I'm sorry. I'm sorry for. I'm sorry. Okay, right. Okay, all right. Then take two more wires and connect them from those power waves to the row where the LED is placed. Once everything is set, plug the Arduino into your computer via a USB. Okay. You plug the USB into your computer. Okay. Make sure that you can see. Okay. Right. Are you ready? Let's go. Okay. Ah, ready. What's wrong with the LED? Right. Let's plug our USB again. All right. It's working. I don't know if you could see. Here you are. Okay. I'm sorry. Yeah. There we go. Okay. Okay. Just a quick note. Normally, you should add a resistor in series with the LEDs to avoid damaging it. But since this is our very first test, you will keep it simple. And if you wire it incorrectly, don't worry. Just swap the connections. The idea here is to learn by trying things out. This first tutorial is purely educational to help you understand how components work and how connections are made. Now that we have wired our first LED CQ, here's something very really cool. You can do this exact same project with any Arduino board you have. I got three of the most both here, the Uno, the Nano, and the Mega 2560. And guess what? The wiring is the same. Let's go for this. Oh, mm, okay. I need some lights. Okay, because okay, right, very good. Uh, let's try with the Arduino Mega. Okay, right. Don't do this at all because you're gonna fire some LEDs. You could do it if you have enough LED like me. I have a bunch of LEDs here, so you can do this if you have enough LED. Okay, right. Okay. Mm. Let's go. Okay. I just change the okay. This is for the the black one is for 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 the GNG and the red one is for the 5 volt. Okay, we're gonna create. Okay, sorry. Right. Okay. Oh, sorry. Okay. Mm. Okay. Right. Are you ready? Ah, first one. Mm. Ah, I'm sorry. I'm gonna change okay. New color. I think this is gonna work. Oh, what's wrong? Mm. Okay, let's do that again. Okay. First plug the USB cable in your PC. Okay. And plug the cable into your oh right, very good. It works. Okay, very good. Okay. Let's change it again. Let's choose the the Arduino the Arduino now. Okay. Oh, mm. Okay. I think. I'm sorry. Okay. Oh, sorry. Okay, right. The black one is for the oh, unplug your cable because it is very dangerous. The black one is for uh the black one is uh for the GNG. Okay, right. Here's the GNG. Okay, this is the ground. The second one is for 5 volts. Okay, right. Okay, here you go. Okay, right. Okay. And now you have to change the USB cover because it's not the same. It doesn't look like as the another one. Okay. First pair it to your PC and then to the Arduino. Very good. I think it is like okay. Yeah. Okay. So ah okay. Well, we have changed the Arduino because so right. That's one of Arduino's biggest strengths. You learn once and it works everywhere. As long as you adjust the board type and come port in the Arduino software, your project will run the same. For example, here's our LED circuit running on the Uno. Now I will move this. I moved the same connection to the Mega and it works also. See, same result. Just make sure to match the pin numbers correctly. For example, if you used 0 pin 8 on the Uno, use 0 pin 8 on the Mega 2. So no matter what board you have in your kit, you can follow along with everything in this course. Arduino makes switching between boards incredibly easy. Great job making it this far. You've learned what Arduino is, explore some way boards, beat your first circuit, and even saw it in action. Now let's take a quick look at what's coming next in this course because we just getting started. Here's what we will be covering step by step. First of all, we master Arduino Basic, digital and analog inputs output, code structure, and serial communication. We work with displays and output devices like buzzers and LCDs and LED matrices. And we're gonna understand logic and timing using conditions, loops, delays, and real-time reaction. We're gonna explore sensors and automation, big projects like a clap switch, touch panel, alarm system, and weather dashboard. Use simulation tools like Tinkercad, phrasing, and others to design and test your secrets. We finish with advanced bits, including IoT, AI basics, robotics, and smart home ideas. Whether you're a student, a teacher, or a curious maker, by the end of this course, you will have the tools, knowledge, and confidence to be reworked working electronic systems. So stick with me and let's keep building awesome things together. That wraps up our first session. Thank you so much for watching and learning with me. I hope you're starting to see just how accessible and exciting Arduino can be, and this is only the beginning. If you found this video helpful, please like, subscribe, and drop a comment to let me know what kind of projects you love to build. And don't forget to turn on notifications so you don't miss the next video where we actually program the Arduino to blink that LED we wired up. Thanks again for joining me, and I will see you in the next one. Let's build something awesome.